Hi everyone, welcome to my channel, Tutorlini Test Prep. Today I'll be providing a full walkthrough of the Digital SAT Math Linear Test Unique number 4. Quick disclaimer, this video will cover the linear non-adaptive SAT practice tests found on College Board's website. Many of the questions from these tests are duplicated in the Blue Book app, which I've already covered in previous videos. This video will cover only the unique questions, so there are no repeats. A link to the linear test unique PDFs will be in the description. I highly recommend you complete the questions yourself before watching this video. Let's get started. Okay, so for this guy, we want to get this square by itself. So how we're going to do that is we're going to move the 25. 25 is being divided, so I'm going to multiply both sides by 25. And we get x squared because these guys go away. And we get x squared equals, what's 25 times 36? 900. And now to get rid of this square, we're going to take the square root of both sides. So we get square root of x squared is x, and 900, that should be 30. Yep. Now, really important, guys, when you get, when you take the square root of a square in an equation, you gotta remember to put a plus or minus on the other side. We don't do it a lot in geometry questions because things like lengths can't be negative, right? Area can't be negative, things like that. But when you have an equation, as long as it doesn't say otherwise, it can be negative. So the answers to this one are really negative 30 and positive 30. So this question wasn't testing us on both, but another one could. So anyway, you see the only one that's on there is B, which is right. So you also could have done this entirely in Desmos, so we don't have any x on the bottom or absolute values. So let's just type in the equation exactly as written, and you see we get 30 and negative 30. Very good, let's move on. Best interpretation of 25 in this context. Okay. So, hopefully you guys can kind of see this is a linear equation, y equals mx plus b. Why don't I actually write this over here? So I'm going to rewrite the problem. And we're going to, I'm going to change the order so that it looks more like mx plus b, so 25t plus 100. And you see, okay, 25 is the slope. So we now have to interpret this 25 as a slope. So what the heck is slope? Well, slope is the change in y. This is almost always how we're going to interpret on the test. It's the change in y when x increases by 1. So it tells you what y changes by when x goes up by 1. So quick example, let's say I have y equals negative 4x plus 2. That's telling us that when x goes up by 1, y goes down by 4 because it's negative. If it were positive, we would say it increases by 4. So change in y when x goes up by 1. So let's see over here. I'm not even looking at the answer, so I'm just going to try to come up with my own. So I'm going to say when, what is x? X is t. When the monthly deposits, or how about for each monthly deposit? That's another way to say when it goes up by 1. For each additional monthly deposit, the y, 25 is positive, so the y goes up by 25. What is y? Y is F, which is the amount in dollars in Hannah's bank account. And again, T is the monthly deposits, which is X. All right, let's go back over here. So the amount in Hannah's bank account goes up or increases by $25. Okay, so see, if you know what the slope is, you can kind of come up with that on your own before looking at the answer choices, and then maybe you'll be less likely to fall for a trap answer. So for each additional x, the y goes up, goes down. So for each additional x, the y increases by 25 because it's positive. All right, now let's look at the answer choices. So it says, I think it's A. It says with each monthly deposit, so when x goes up by 1, the amount in Hannah's bank account increased by $25. Let's see if that's right. Yep, it's right. Let's try to decompose these other ones, maybe briefly talk about why they're wrong. So 25 monthly deposits, what? Like, that's just telling you, I don't think there's any way to figure that out from the question, how many total deposits she made. It doesn't say. That's just telling you like an x value of 25. That's not a slope. So that's not right. Let's see. After one monthly deposit, the amount in Hannah's bank account was $25. That's not even right. So if we made x is 1, you would do 25 times 1 plus 100 based on the equation, right? That would actually be 125. So not only is that not a slope, that's not even correct anyway. So so that's no good. Let's see. Before Hannah made any monthly deposits, the amount in her bank account was $25. So that's telling you when t or x is 0, and we've talked about this a lot in this series so far. When x is 0, that's your y-intercept. That's talking about the b, the y-intercept, which is 100. So not only is it wrong, even if it were right, even if it said 100, that's talking about the y-intercept, not the slope, which is what the question asked us about, the 25. So before Hannah made any monthly deposits, the amount in her bank account was $100. That would be the interpretation, if that were correct, that would be the interpretation of the y-intercept. So you see, like, they'll put, like, you know, often when they ask you for the slope or the y-intercept, they'll put, like, the one they're not asking you for. And it sounds right, because it is right, or mostly right in this case, but it's not what they're asking you for. So that's kind of what makes these questions so confusing, is they'll put correct stuff in the answer choices, but it's not what they're asking you about. So always make sure you pay attention to what they're asking you about. Great. All right, these are always kind of a pain, I feel, for you guys, because on the test you can't actually draw on the graph like I'm about to do, but we want to draw the line of best fit. So with your mind's eye, just kind of, you know, try to draw a line going through like the middle of the data. So I don't know, that's the best I can do really without a ruler. I've noticed on the Blue Book test they put the dots closer together to make it more obvious. Okay, so right away I'm going to pick out the y-intercept. The y-intercept seems to be about positive 9. And 0.9, 0.9. Okay, those are wrong. Those are wrong y-intercepts. So those are out right away. And now I don't even need to calculate the slope. I just need to know that, you know, positive slopes, the line goes up. Negative slope, the line goes down. And of course, equal to 0 is perfectly flat. So this one's going down as I go from left to right. So the slope must be negative. So this positive slope here, hold on. Yeah, just that, the 0.9. That is wrong. So it's got to be D. We have a y-intercept of about 9 and then a negative slope. So it's the only one that has that. We don't even need to do any computations. We can just do process of elimination. And the answer is D. Okay, great. Which is following the best interpretation of f of 5 is equal to 243. Okay, so talked about this many times in this series at this point. So the first guy is your x, okay? The x is the thing inside the parentheses. In this case, they just use x. So that guy is x. And the guy in front is your y, which is the number on the other side. So this guy is f. And I'll label that with green so you guys can kind of follow my little color coding here. So x is 5. Let's see, what the heck did they say x is? I'm not even reading the question. X is the number of years after 1957. So 5 years after 1957. Okay, 1957, we're doing 5 years after, so that's plus 5. So that's 1962. Okay, now let's write f equals 243. Let's see what they say f is. They say the function f of x models the value in dollars of a certain bank account. Okay, so I guess it's just $243 value. So we should be looking for mentions of 1962 and a $243 value. So the $243 value in 1962. Okay, let's see. Pretty sure that's B, right? Let's check. Yeah, that's right. The value of the bank account is estimated to be approximately $243 in 1962. Great, that's exactly what we came up with. Let's go over some of the problems in the other ones. Approximately $5 greater in 1962 than in 1997. Not only, let's think about that. Is that true? When x is 0, the in 1957, it's 206. So 243 minus 206. It's really $37 greater. But even if that were right, it's not the interpretation of the point. The one point doesn't tell you anything else about another point, right? So this one's wrong for a lot of reasons. It's not really $5 greater. It's $37 greater. And even if they did put that, it's still wrong because it's not what they're asking you. All right, let's look at the other ones. Approximately 5 times greater in 1962. Okay, so we would do 243 divided by 206. That's actually 1.1796 times greater. And again, even if that were correct, the point doesn't tell you anything about what that value is in comparison to 1957, so even if it were written correctly, it would still be wrong. Okay, the value of the bank account is estimated to increase by approximately $243 every 5 years. So that would be like, that's telling you a slope, which would be if this were like a linear function. Which again, this has nothing to do with a point. I'm just telling you how they came up with these trap answers. This is not a linear function. This is an exponential function. So anything that sounds like slope should just be wrong. You don't even need to check it. It's an exponential function, so it's not going up by $243. It's getting multiplied by something every year. In particular, it's getting multiplied by 1.034 every year. Great. So yeah, I wouldn't even look at the trap answers. I would try to come up with it yourself and then just compare what you wrote down to the answers and use that to pick the answer. Great, let's keep going. Square Q has a perimeter that is 176 inches greater than the perimeter of square P. Okay, let's draw this out. Really quick, just context that's not on the formula sheet. For squares, all the sides are the same, right? So the area is s squared. And why don't I actually put this down here? Hold on. So the area is s squared, s times s, and the perimeter is 4 times s. Those are just some things you might want to know. Okay, so square P has a side length of x. So let's do P, and then we'll do Q. So P has a side length of x. So that makes the perimeter four times x. And Q has a perimeter that is 176 greater. So his perimeter is going to be 4x plus 176. And we want the area of square Q. So remember, guys, the perimeter is equal to 4s. So we want to find the side length of Q. So we're going to divide both sides by 4. So divide both sides by 4, and we get x plus, I don't know what 176 divided by 4 is. Hold on. 44 equals s. And remember that area equals s squared, which for this guy would be x plus 44 squared. That should be answer choice A. Let's see if that's right. Yeah, that's right. So, great. So you see, like, all the sides on this guy are x plus 44. So yeah, we had to know our equations for perimeter and area of a square. We had to do a little bit of words to math where we, then, the perimeter is 4x, and then we added 176. But the big important thing was that you had to realize, wait a minute, I have this. In order to get area, I need to figure out s. So we had to divide both sides by 4 to get s by itself and then put it into the area formula. I'm trying to think if there's a good way to do this using Desmos? I don't think so. I mean you certainly can do your work on Desmos, but there's a lot of words to math on this problem, so you definitely have to know some stuff. So all right, let's keep going. All right, this looks tricky. We have a tricky these are called literal equations. So if you want to look this up on YouTube, like Khan Academy or Google, Algebra 1, literal equations. That's the that's what you got to know. I say this all the time in my videos. These questions are really difficult, and they're going to be different every time. So if you're not willing to put in the time to get good at this, maybe just focus on other questions, because these can be very hard, and this one certainly looks at least a little tricky. Okay, so whenever it says in terms of, the thing you want to get by itself is right before it. That's W. So you see we want to get W by itself. So kind of like I'm going to move the stuff farthest away from the W first. So the 19 is in that little house with him, right? So we're going to move the 2 first. So I'm going to divide both sides by 2. And we get 14x over 7 times 2 is 14y. Well, 14 divided by 14, that's just 1, right? So that just goes away. So we have x divided by y equals, these 2's go away. We just have square root of w plus 19. Now I have to get rid of that square root. So I'm going to square both sides. And I have x over y squared. The radical goes away. And we're left with w plus 19. And now I'm going to subtract 19 from both sides. And we get x over y squared equals w. Oh, sorry. Minus 19 equals w. And that should be C. It's really aggravating because you might distribute or write this in a different order, and because it's multiple choice, you need to get it. You might be right still, but because it's multiple choice, you need to get it to look like exactly like the answer choices. And I was just kind of subconsciously planning to make it look like the answer choice while I was showing you guys. Obviously, you know, not everyone's gonna be able to do that. So, yeah, these are hard questions. So if you didn't have at least a semblance of that kind of plan in mind, and your test is coming up, you might just want to focus on other questions that are easier to learn more quickly. Let me check, make sure that's right. 1.19 is C. Very good. And again, these are called literal equations, so please, there's an endless plethora of videos on YouTube and Google and Khan Academy about literal equations. You can find tons of worksheets. Just, you know, check it out. Okay, lots of stuff going on here. We have to get ax to the b. So we basically need to rewrite all of this without radicals. And, you know, something we probably just want to know, I went over this in one of the other videos, bx to the a is equal to x to the a over b. And similarly, so let's just do a really, really quick example. So let's say I have cube root of x squared. That would be x to the 2 over 3. I talked about this in more detail in one of the previous videos. Check it out. Fractional exponents, exponents and roots, if you go to search it up. So just make sure you understand that the guy that's here goes here, and the guy that's here goes here. So power root, power root. So the power goes on top, the root goes on the bottom. And of course, make sure you understand that an empty exponent, you put a 1. An empty root, you put a 2. So for example, square root of x is x to the 1/2. Also, you're going to want to understand that roots can be broken up. So let's say I have the 5th root of 2 to the 3rd x to the 4th. So you can break these up into, when they're being multiplied or divided, you could put them under their own roots. So you could make this 5th root 2 to the 3, 5th root x to the 4, and then I could make that 2 to the 3/5 and x to the 4/5. You can't do that when they're being added and subtracted, only when they're being multiplied and divided. Okay, great. So let's try this one now. So 6, I'm going to rewrite it as 5th root 3 to the 5th. And then I'm going to break it up. 5th root x to the 45 times 8th root 2 to the 8. And then 8th root of x. Now, this one is 3 to the 5 over 5. 5 over 5 is just 1. And 3 to the 1, anything to the 1 is itself. So 3 to the 1 is just 3. And then this guy is 45 power over root. 45 over 5. 45 divided by 5 is 9. So it's x to the 9. And then this one, similar kind of deal. 2 to the 8 over 8, which is just 1, which is just 2. And then this guy, remember, empty exponent, so we put a 1 there. X to the 1 over 8. Okay, now we can just, let's do all the numbers together. So 6 times 3 times 2. What is that? 36. And then now we're going to do the x's together. So x to the 9 times x to the 1/8. Rules of exponents tells us that when we multiply by a common base, we need to keep the base and add the exponents. So I'm not going to do that fraction math in my head. I'm just going to do 9 plus 1/8 off to the side. And we get 73 over 8, or 9.125. I'll just put 9.125 because it comes out nicely. Okay, so now it says, this is really important. You see how it says you're going to write it as ax to the b? So a is 36 and b is 9.125. So you're going to do a plus b, add those guys. 36 plus 9.125, which is 45.125, which is correct. And you also could have put that as a fraction. Like I said, you could have just left it as fractions. 361 over 8. I don't think this question is too bad, but I think the biggest problem is a lot of people, because this is a free response, a student-produced response, lots of people are going to see this and just have no idea what to begin, right? Like if I was sitting there while you were taking your test and I told you, hey, just start, changing the radicals to exponents, you'd probably be able to figure it out. But many people would just get stuck because they don't know what the question's asking them. So I guess the biggest thing that clued me in that I had to do that was, I've done many SATs, but that yellow part where it says ax to the b, um, I I noticed that look, there's no radicals here. So I went, oh, why don't I try to just change everything to a fractional exponent, and you see it worked out pretty nicely. So great, let's keep going. Right triangle has side lengths. Let me pull something up from the reference sheet. Okay, great. So we got a right triangle, so that means it has a right angle. And I don't know which of these, I'm not really sure which of these are the legs and which of these are the hypotenuse. So let's just type all these in and get the decimals. Okay, it seems like square root 80 is the biggest. So that has to go on the hypotenuse, and the other ones go on the legs. So the hypotenuse is across from the right angle. So square root 80 has to go there. And then the other ones, 2 root 2 and 6 root 2, those go on the legs. So it doesn't matter where you put those. Now, the formula for the area of a triangle is 1/2 base times height. And you see, oh, this doesn't really, this is what it looks like on the reference sheet. You're like, what the heck is the base and what the heck is the height? Well, see how the perpendicular distance from the base to the top is that side, right? So right triangles, the base and the height are just the two legs. That's it. So that's just something you want to know. So like, you don't have to draw a height. Like one of the legs is the height, depending on how you draw it. It doesn't matter. So we have a right triangle. The base and the height are the two legs, the shorter sides. Okay, so we're going to put in 1/2 base, at least how I drew it, is 6 root 2, and then height is 2 root 2. And you could, if it came out messily, you could just do that on a nice scientific calculator, but this one actually should come out nicely because root 2 times root 2 is just 2. But regardless, even if you didn't have a nice calculator, because it's multiple choice, you could type that in and then compare the decimal to the answer choice. Anyway, we don't have to worry about that because it comes out to 12. So the area is 12, which is answer choice B. See if that's right. That is right. Okay, so don't forget, guys, area formulas, a lot of them are on the reference sheet. And the longest side, when they give you 3 sides of a triangle, the longest side has to be the hypotenuse in a right triangle, and the legs represent the base and the height. So probably these trap answers come from like putting the root 80 like as the base or the height, which is wrong. Great. Okay, negative a to the x plus b, where a and b are constants. I wonder, is this the same? It's definitely very similar. I don't think it's the same numbers. It's definitely very similar to the sample questions. I feel like I've done this one before, but let's just... Hold on, give me 1 second. Okay, yeah, there's just an incredibly similar question, literally with like only one or two of the numbers changed. Three of the numbers changed in the skills insight tool. So just want to make sure this wasn't one that I already did. Anyway, so um, um, we're going to first write y equals f of x minus 15. So just replace this with f of x. So y equals negative a to the x plus b minus 15. Now we're going to plug in the point. 0, negative 99 over 7. So negative 99 over 7 equals negative a to the 0 plus b minus 15. Okay, a to the 0 is just 1. So negative a to the 0 is just negative 1. So that becomes negative 99 over 7 equals b. Negative 1 minus 15 is negative 16. Now we're going to add 16 to both sides. I have no idea what that is, so let's see what we get. Okay, that is 13 over 7. So 13 over 7 is b, and now it says the product of a and b, so that's just a times b, is equal to 65 over 7. Let me just highlight like the really important parts here. So b, we're going to substitute now, is 13 over 7. And we're going to divide both sides by 13 over 7, which is the same as multiplying by the reciprocal. So you can multiply both sides by like 7 over 13. And then this guy will go away, and this guy will go away. And you see these 7s go away. And we get 65 over 13, which is, let me say, oh, what is 65 divided by 13? Which is 5. So that is the answer. Okay, guys, sorry about that. I must have accidentally paused the recording. So I just want to show you really quickly that last part we could do, so 65 divided by 7. Even if you didn't know how to do that, which you should, because you're going to have to do it for symbolic questions, you could have did the fraction math on Desmos just to save you some stress, make sure you're doing it right. So you just press the division sign twice. Okay, great. Let's keep going. So this is a unit conversion problem. And I just made a video on this, Ottocento number 2. You definitely want to check this out. We're going to do a unit conversion using the factor label method. So first I'm going to write down the thing they gave me, 5104 yards. And now I'm going to make sure, okay, we want yards and miles. So everything looks good. We don't need to do anything to the conversion factor. And I'm going to put 1760 yards on the bottom. And I'm going to put 1 mile on the top so that when I go to draw my little division bar fence, yards is on opposite side of the division sign, so it cancels. And we're left with miles, which is what we want. Okay, now we just got to put that in our calculator. So 5104 parentheses 1 over 1760. And we get 2.9. So this is 2.9 miles. Definitely go check out my other video on this. That is answer choice B, which is right. Okay, this is combining like terms. So in order to combine like terms, all we need to do is just check to make sure the thing after the numbers, we got the same variables and the same exponents and same everything. right? So 12 minus 5 is 7. Because they're like terms, I can just write 7 and then keep the rest of the term, x cubed. That is answer choice C. Of course, if you weren't sure with any equivalent expression question with just x's in it, you could graph the first one and then graph the 4 answer choices and see which one matches the question. All right, what is the total number of people on a company retreat with 7 managers? Okay, so the number of managers is x. So this is basically just telling us x is 7. So we're going to make x 7. So we do f of 7 equals 7 and replace that x with a 7. And that should give us 50. So 50 people on the company retreat. Of course, you can evaluate functions using Desmos. So let's say f of 7 gives me 50. So we probably did a good job. Let's check. Good. All right, let's keep going. Okay, this one says if one of these tiles is selected at random. So probability, remember guys, is desired over total. And they're all tiles, right? So that 100 is going to be our total. If it said just if one of the red tiles or if one of the pentagons is selected at random, then your total might be something different. You might have to like circle a row or column and then use the total in that row or column. But because they told us if one of the tiles is selected at random and they're all tiles, our total is going to be that number in the bottom right, which they also give to us in the sentence, which is 100. Now we want a red tile, so we don't care if it's square or pentagon. We just want the total number of red tiles, which is 30. So we're going to do 30 over 100. We're going to either want to put that as a decimal if it comes out nice, or simplify it. So you could have put 0.3 or 1 or 3/10. I'll just put 0.3. If it comes out nicely, I don't see any reason not to use the decimal, but totally up to you for this one. If it's a messy decimal, I definitely wouldn't risk it. Just use the fraction. Great, that is right. Let's keep going. Okay, not really sure what's going on with this question. Parallel lines have the same slope. That's the first thing that should be going through your head. So mx plus b. So the slope is 2. So the slope of the parallel line, line J, is the same. So it's also 2. That is it. All right, really strange. Okay. In the given equation, P is a constant. The equation has no solution. Okay, I'm going to pause the video and put some notes up on the board. So I've shown this chart many times now at this point, but you want to make sure you know that when you have slope-intercept, no solution, same slope, different y-intercepts. One solution means they have different slopes, and infinitely many means they have the same slope and the same y-intercept. So please pause this video, take a second to jot this down if you don't already have this written down or know it by heart. Okay, so what we're going to do for this one is we're just going to make it look like mx plus b. So what I'm going to do is, there's a couple ways you could approach this, but I'm going to add 3x to both sides. I can't combine these because that one has a p and that one doesn't, which would be really convenient. But so we're going to add 3x to both sides. So it looks like this. 21px is equal to 3x plus 84. And now you can kind of see, now that I've done that, oh, this is like mx plus b equals mx plus b. So we want no solution. So they should have the same slope and different y-intercepts. Well, different y-intercepts probably isn't going to help us find the problem, so let's focus on same slope. So the slope of this side is 3, and the slope of this side, the thing in front of x, is 21p. So if they're the same, that means they're equal, so 21p is equal to 3. Now we're going to divide both sides by 21, and you should get 3 over 21, which is 1/7. And once again, if you weren't sure about that, you could simplify it using Desmos. All right, so that's 1/7, and that should be our answer. Now, I want to point out, we could have, because it's multiple choice, we could have done this guy entirely on Desmos without knowing anything. So negative 3x plus 21px equals 84. And we're going to make p, let's do answer choice A, 0. Okay, so that has one solution. So that's not no solution. Let's do the other wrong answer choices. 4/3. That's got a red line. That's got one solution. Let's do 4. That's got a red line. That's got one solution. And 1/7. No solution. See, no matter how far you zoom out, the equation does not have a solution. So that's another way you could have figured out the answer really quickly. I went over that in one of my Desmos videos. How many solutions, guess and check, multiple choice. All right, let's keep going. For what value of x does f of x reach its minimum? Okay, so this, whenever you see a minimum or maximum for a quadratic problem, you should be thinking about the vertex. So, in particular, we want the x-coordinate of the vertex because it says x. If it just said, what is the minimum, we want the y value. But because it says, what value of x does it reach its minimum, you want the x value. So it wants the x-coordinate of the vertex, which we call h. This guy is in factored form, which you definitely want to know for the SAT. So a times x minus s, x minus t, factored form of a quadratic. So the easiest way to get the x-coordinate of the vertex h from factored form is you find the two roots and you average them. So that's what we're going to do. So y equals x minus 10, x plus 13. So set each of those factors equal to 0. So x minus 10 equals 0. So x equals 10. And this one is x equals negative 13. Those are your x-intercepts. Now we're going to do h equals s plus t over 2. So we're going to do 10 plus negative 13 over 2. That gives us negative 3 over 2, which is answer choice D. And that is correct. So that is how you do it by hand. And of course, this entire question you could solve very easily using Desmos. So let's go over that. You still need to know how to do it for harder questions. So please make sure you know how to do it by hand as well. Okay, so you see the x-intercepts are 10 and negative 13, which is what we found. And the vertex is this point at the very edge. So the x-coordinate is negative 1.5, which we could then just quickly go over here. And we could type negative 1.5. And we get negative 3 over 2. Very easy. Probably would took about 10 seconds. All right. Okay, so for this guy, let me pull up some notes first. Okay, we went over this in the last video. The discriminant is b squared minus 4ac. When b squared minus 4ac is less than 0, you have no real solutions. When b squared minus 4ac is equal to 0, you have one real solution. And when b squared minus 4ac is greater than 0, we have two real solutions. This is what we use for quadratics. What we were talking about before was for linear systems. This is for quadratics. Pause this video, make sure you have this written down somewhere because it's not on the formula sheet and you definitely need to know it for the SAT. Okay, so we have a quadratic. And we probably have to it says we have no real solution. So that means b squared minus 4ac, the discriminant, is going to be less than 0. So negative. All right, let's quickly figure out what a, b, and c are. So a is negative 1. So we get that from there. B is just whatever's in front of x. So that is b. So it's just b. And then c is negative 676. Okay, so now we just plug that in. So let's see. So b is just b. So b squared minus 4, a is negative 1, and then c is negative 676. Okay, let's see what negative 4 times negative 1 times negative 676 is. That's minus 2704. Now I'm going to add 2704 to both sides, and I get b squared is less than 2704. Now we're going to take the square root of both sides, and we get b is less than, and we don't have to worry about plus or minus or anything because it says b is a positive integer. So that is super important. So b, so now I would go on my calculator, and I get b is less than 52. It actually comes out nicely. Good. So if b is less than 52 and it wants to know what is the greatest possible value of b, well, you can't say 52 because 52 is not less than 52. It's equal to 52. So the next biggest possible integer is 51. And that is correct. Great. All right. So, could you do this on Desmos? That's a great question. Probably, yeah, using the slider. I'm gonna do. I'm gonna go ahead and make it like separate equations so we can graph it, and hopefully that'll tell us what's going on more easily. So I'm going to do y equals the left-hand side, and then y equals the right-hand side. And I don't even know, this is we're gonna have to zoom out a ton. Okay, here we go. So see if we move b around, the graph moved, but we know it's a positive integer. So why don't we do make b from 1 to 100 with a step of 1. And you see, oh, somewhere over there, right? So let's just zoom in. So here it has 2 real solutions. Again, I'm seeing it's somewhere between like 52 and it's somewhere between like 47 and 55. So why don't we change that? So 47 to 55. And I'm going to make the speed slower. And you can see like right there at 52, it's touching. So that means it has 1 solution. But we want the biggest with no real solution. So see down here at 51, it doesn't cross. So yeah, you could have got this one because they told us it had to be an integer. You could have gotten this one using the slider very easily. You could have, just typed in x squared plus b exponent 676 equals 0, but I just think this is so much nicer as a graph because you can actually kind of see what's happening. Like, don't you learn so much more from typing it in like this than just seeing a bunch of vertical red lines, right? Anyway, all right, great, really cool. That was one of the most helpful questions I've ever seen with the slider. Okay, so if a new graph of 3 linear equations is created using system equations shown and the equation, okay, so we just have to I'm gonna make a picture on Desmos just because I wanna, but so here's kind of the idea. So a system of 3 equations only has a solution if all 3 of them are touching at the same point. So like this would be a solution. But if just 2 of them are touching, like over here, that is not a solution. So when you have 3 equations, all 3 have to be touching. It's been a really long time since they've asked about this. Anyway, so you can kind of see this guy only has 1 solution, and it is 8, 2. So if we chuck in that 3rd equation, it's either going to have 1 solution if it goes through that point, or it's going to have 0 if it doesn't go through that point. So the point is 8, 2. So let's just see x plus 4y equals negative 16. So 8 plus 4 times 2. So 16 equals negative 16. So that point, that is not equal. So this point does not fall on the line. So there's not going to be anywhere where all 3 of them touch. So this guy is going to be 0 solutions. And that is answer choice A. Let's see if that's right. It is. Good. So if you wanted to, you could come up with the equations for those other 2 and then plot all of them. So I'm going to do that now just for the sake of it. Probably wouldn't do that on test day. So that's horizontal line. Horizontal line start with y equals. So y equals 2. And now this guy, it's got a y-intercept of 4. And it's got a slope of rise over on negative 1/4. So this is negative 1/4 x plus 4. Okay, let's see what that looks like. Okay, so we got y equals negative 1/4 x plus 4, and we got y equals 2. That looks pretty good so far, right? I think I did that right. Did that kind of fast, but now let's do the other one. X plus 4y equals negative 16. And you see there are points that the green one that we just added, it touches the blue one, and I don't think it touches the red one, but my point is there isn't any point where all 3 of these touch. which is what the question is asking you for. So, so that's it. Yep. Let's keep going. So, again, keyword here being solutions to the resulting system of all three equations. Okay. So, when we shift a circle, we can just pay attention to its center. You don't need to do anything with function translations and stuff. So the equation of a circle is x minus h squared plus y minus k squared equals r squared. The one they gave us was x squared plus y minus 1 squared equals 49. So the center is going to be, okay, there's no number there, so that x coordinate is going to be 0. And then remember, it's not -1. You have to change the sign because there's a minus sign here. So it's +1. Lots of people would have said 0, -1 and gotten it wrong. The radius is the square root of 49. You got to take the square root of that number, whatever number is there. And we get 7. You don't even need that to solve the problem, but see how they all have 49 anyway, so it doesn't matter. All right, so we're going to do 2 down 2 units. Okay, so the y coordinate is going to go down by 2. So it's going to become, the new center is going to be 0, -1 with a radius of 7. And if we plug that into the original equation, we get x minus 0 squared, which is just x squared, plus y minus -1, which is just y plus 1 squared, equals 7 squared, which is just 49. So that is answer choice D. Let's see if that's right. Yep, very good. Okay, so I've gone over a lot on my channel how to like do function translations, both implicitly and explicitly. When you have a function like a quadratic or a circle, you can just pay attention to whatever the special point is. So like the special point for a quadratic is the vertex, right? The special point for a circle is the center. So you could just change the center however you want. If it said go 2 right or like 8 right, we would like add 8 to x. So hopefully that kind of makes sense. 210 is p% greater than 30. Okay, guys, I had to go back and redo this one because I did this in a really long, complex, roundabout way when I didn't have to. This is testing you on the percent change formula. I went over this in the Ottocento video. It's new minus old divided by old times 100. So let's make a little table. We want, as we go from old to new, we want to be greater. So we want the 30 on the left and the 210 on the right. We want it to be getting bigger as we go from old to new. So our old is going to be 30 and our new is going to be 210. So now we just plug in the numbers. So 210 minus 30 divided by 30 times 100. And let's see what that gives us. So fraction bar 210 minus 30 divided by 30 times 100. And we get 600. So the percent change is positive 600%, which is a 600% increase, which is what the question wanted us to find. So P would be 600. Hope that helps. I was really confused as to why like the percent change formula was like the last question on the exam. That didn't make any sense to me. I guess that's probably why I did it wrong the first time. Not wrong, but a different way. Okay, that completes the lesson. Please like and subscribe for more digital SAT math content. If you're interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.